Good evening. So thanks very much for coming this evening. It's great to have you. This is actually the first time we're running this competition. We really didn't know what to expect. We didn't know what to expect. We didn't know if we were going to get any applications whatsoever, let alone the quality and quantity which we've received. We've been really positively impressed by everything we received. So tonight we're going to have 11 teams pitching for £10,000 proof of concept further development funding. And thank you very much. Thanks. And the sort of underlying philosophy behind this whole competition is around this notion that software is eating the world. And this is, of course, a famous quote, which I'm sure a few of you know about, a famous Mark Andreessen quote. And it's this underlying concept that we're seeing the proliferation of software into everything. And this means, essentially, the disruption of undigitized space right now. And it means that opportunities abound in bringing efficiencies in currently outdated industries. So we're going to see this tonight. We're going to see this and really this slide is all about understanding that we're here to show the proliferation in many different fields. So we were told to maybe narrow the scope of this competition, but we decided to keep it broad, keep it generic, so we could really look at the strength and breadth of the different application areas coming out of the college. So we've teamed up, us Imperial Innovations have teamed up with Imperial Enterprise Lab to deliver this competition. So we're going to see all kinds of different application areas, including but not limited to clean tech, smart contracts, fintech, and other fields like that. So, as I mentioned, the format's going to be a 5-minute pitching session by all the teams, followed by 2 minutes Q&A by the judges. And the judges tonight, we're very honored to have 4 great judges. So starting off with Lamia Baker. So Lamia is a senior technology licensing executive at Imperial Innovations. She has over 15 years experience in the high-tech industry, including VC, and 7 years in high-growth telecoms companies in the Boston area. A physicist and engineer by training, she has worked in tech commercialization on all sides, VC, startups, and now tech transfer. We have Chris Corbishley, who has founded an advanced analytics meets e-commerce business called Growth Squared, having previously been the head of analytics at Swoon Editions. He completed a PhD here at Imperial College and returned as a venture coach in residence at Enterprise Lab. He's also worked with the London Stock Exchange Elite Programme, which provides the UK's fastest growing companies with business support tools and education services. We then are honored to have Paul Dowling, who is the founder and CEO of DreamStake, which is a venture platform focusing on the intersection of deep tech, such as AI and machine learning applied to industry sectors such as health and retail. So Paul has over 30 years experience working with technology for companies such as Vodafone and Capgemini. He has also worked as an independent strategy consultant for Oracle, Wipro, and Sapient. He now manages a network of over 2,000 technology startups, runs a European startups on Facebook, and a monthly mixer called Deep Tech Mondays. And finally, Nick Thorne is the head of platform at Yo-Yo Wallet, which is one of the spin-out companies coming out of Imperial College, coordinating the development across 5 teams, comprising around about 30 engineers, product managers, and designers. So he's also an Imperial College graduate, and his responsibilities now include delivery of product for Yo-Yo's partnership with Cafe Nero and user-based growth. So these judges will be assessing the pitches primarily around impact, so that's both social, societal, as well as commercial, usability and user-centered design, as well as the ingenuity. So that's both technical ingenuity, but just generally any kind of inventiveness that's led to overcoming high barriers to entry that the teams have had to overcome. So as I mentioned, it's a 10,000 proof of concept fund for the further development of these new technologies and ideas. And well, without further ado, let's kick things off with David Shah. David Shah will be presenting, 'Circuit Box'.
Hello, I'm David. I'm an EIE student here at Imperial, second year undergraduate, and today I'm presenting my project CircuitBox. CircuitBox is a simple and easy to use electronic circuit simulator and circuit design tool aimed at pre-university EIE students and almost anyone else who's interested in electronics. The overall aim of the project is to allow millions of potential users to learn electronics and design circuits with the lowest possible barrier to entry. At the moment, the project exists in the form of a PC application. I've been working on this for a few years. It's been used extensively in my former school. I have also made it available for a free download online, although I haven't put any effort into promoting it, so it's only had a few hundred downloads. The idea is to have a very graphical interface. The user builds their circuit on the virtual breadboard using fairly realistic component images and then simulates it in real time. They can see how the circuit will behave in real time. Components will update. Here's a slightly more complicated circuit showing, for example, how displays would appear in the simulation. This is a timer circuit. So as mentioned at the moment, it's in the form of a PC application with the virtual breadboard interface. That's the prototyping technology that I simulate in the UI. And the simulator core itself is pretty capable at the moment. I use sparse matrices and on-the-fly code generation to improve performance, so it can simulate even fairly complicated circuits in real time. In the future, I want to extend it to be not just a PC application, but also a mobile app with built-in tutorials to further lower the barrier to entry. I want to improve the digital side of the simulator performance for digital circuits. That way I can add support for the Arduino processor platform that I'm sure some of you have heard of, and common Arduino peripherals, such as small LCD displays, as these are very commonly used in educational and hobby electronics. In terms of target markets, the PC application would mostly be used in schools realistically, and that could be monetized fairly easily by selling site licenses. The mobile app would be aimed at young people everywhere, and that would be a free download because, again, we want to minimize the barrier to entry. Nonetheless, it could be monetized using advertising or in-app purchases for extra functionality. At the moment, there's massively increasing smartphone usage and a big focus on technical education in developing countries. And this app could really catch that wave, and it could be the app that teaches millions of children about electronics. So I'm sure some of you may know there are circuit simulators out there already. So the question is, how is this one different? Well, first of all, it's easy and it's also quite fun and pleasant to use, and you don't need electronics knowledge to use it. That's unlike a lot of the more production-level tools that would be used, for example, on higher-level university courses and at companies. Unlike a lot of the more educational tools, it is capable of simulating more advanced circuits without crashing or failing, so it doesn't limit learning in that regard. There's a tool out there very popular in UK schools called Circuit Wizard. I'm a geek. I bought it with my pocket money when I was 8 or 9. I was playing about with it, built what I thought was a fairly simple circuit, but a bit beyond what it was supposed to do, and it crashed with a floating point error. Mine, I hope, wouldn't do that, so it doesn't limit how far you can go, you can grow with it. In the future, the mobile application and the Arduino support will both differentiate it from other products that are out there already. There's currently one other attempt on the market at a mobile circuit simulator, but it doesn't really fulfill either of the first 2 points here. It's neither easy to use nor particularly powerful. So as I said, although the mobile application is still a work in progress, I have worked on some sketches of its user interface. The aim is to base it on the PC's user interface, but make it bigger with nice clear buttons and make it even more graphical as well. So for example, here's what the component picker would look like. If I were to win the £10,000, my main focus would be on targeted marketing once I'd considered the costs of bringing the application to market, for example, licensing third-party frameworks or libraries. So the aim would be to spend half the money getting the PC app into schools, promoting it to them, getting them to use it, and the other half spent promoting the mobile application more generally. That way, that gets people talking about the app, and then hopefully it can reach the point that it promotes itself. Thanks for listening, and I welcome any questions.
So maybe just as a first question, have you thought of protecting the intellectual property, considering that there are many larger players that could, quite easily enter this market due to their expertise in the area?
Not yet, but if I came up with any innovation, particularly in terms of how I do the mobile interface. I think that's probably the biggest scope for innovation, would be how to get a really nice interface on a mobile device. Then that is something to consider protecting, but it's not something that I've considered yet. No, not particularly.
Have you? Oh, sorry. Have you considered the timescales it takes to sell EdTech into a public organisations like schools?
It seems that there have been some fairly fast growers in this market, but looking at some of the circuit simulators that other people have tried, that in my opinion are nowhere near as good, it does seem that one or two do seem to be picking up, but there would certainly be time to get people talking about it and, you know, get schools using it, give it away for free at first probably, and then hopefully they talk about it and it spreads.
I'd like to ask why you're prioritising a mobile application over, say, a web-based application.
The main reason is because the web-based apps at the moment, they tend to be very demanding on connectivity because they need to get data back kind of in real time from the simulator. Because running the simulator in JavaScript is just not possible at the moment. There's just not enough performance. So you have to run the simulator on a server. And then if you want it to be nice and interactive, you need quite a low latency connection, and that has a lot of limitations. And just getting the slick UI, there is one attempt at a web-based simulator. It just doesn't work at all. The UI is just not nice at all.
Will you not have the same problems with a mobile application?
I don't think so, no, because you're running the UI natively. And the performance of mobile devices is actually, I started developing this on a laptop a few years ago. A modern-day phone is just as powerful as that laptop, to be honest.
Thanks very much. So just to be clear, we're going to have the 2-minute Q&A from the judges, but we are going to have an open Q&A towards the end where anyone is open to ask any questions to any of the teams. So next up, we have James Alden with Climate Edge.
Did you know that in the UK alone, 640 cups of coffee are drunk every second? But even more impressive is that 80% of these cups will have been made from beans produced by smallholder farmers. I'm James, co-founder of Climate Edge, and we're bringing data to action for smallholder agriculture, starting with coffee. Now, this fact might seem rather glamorous, but in reality, farming in the tropics is hard. And now, with the added pressure of climate change, it's becoming even harder. For example, the recent coffee rust outbreaks resulted in average annual yield losses of 20% and monetary losses of over $1 billion in Central America alone. And this fungus thrived due to unusually high air temperatures and humidity caused by climate change. This is a huge problem, and why organisations from the FAO to Fairtrade International are dedicated to developing strategies to enable farmers to adapt to climate change. Solutions such as new management practices, improved coffee varieties, and farmer field schools have all helped increase productivity during small trials of less than 10,000 farmers. However, every farm is unique, so identifying which farm requires which solution is an expensive and labour-intensive endeavour, and consequently, nearly all of the 25 million smallholder coffee farmers worldwide are left to make decisions on their own. And the stakes are alarmingly high if they get these decisions wrong. Poor yields in 1 year can lead to months of malnutrition and prevent the farmer from sending his children to school. Climate Edge are closing this gap, ensuring that organisations can provide the millions of farmers with the support they need. Our weather stations diagnose how the key climatic variables, air temperature, humidity, and soil temperature, are reducing yields on individual farms. And our integrated web platform allows our partners to be able to identify and implement the correct solution tailored to those individuals. By understanding the smallholder market, we have created a weather station which specifically addresses our users' needs. At $150, it's 1/20th of the price of our closest competitor. We collect data on farm, remote data transfer comes as standard, and our plug-and-play design removes all technical barriers to use. But the hardware alone is just a tool. Our integrated web platform analyzes this data and, combined with the expertise of our partners, provides farmers with the necessary information they need to make and implement those correct solutions. Our business model is to charge a subscription, which provides access to the data and the platform for $10 a month, and to distribute the weather stations for free, making our system affordable for the smallholder market. and the valuable data collected from our weather stations enables us to generate additional revenue from other industries. We piloted our first prototypes with Fairtrade International last year, and all 10 farmers expressed the importance of being able to take control of their livelihoods in the face of climate change. Some even travelled for over 4 hours to discuss their results with us. Since the trial, we've received a number of inquiries from farmers and cooperatives about when our tools will be ready for purchase. And they'll be market ready by the end of this month. And our initial step is to penetrate our initial market of early adopter farmers who own a mobile phone and belong to one of our already partnered organisations. And this alone equates to 180,000 farmers. We're starting in selected Latin American and African countries with strong cooperative networks, which provides us the infrastructural basis to be able to spread our products. But we foresee our approach being accessible to all 25 million smallholder coffee farmers worldwide, and even beyond coffee as well. We have a talented technical team who have experienced both taking software and hardware products to market, but our company's biggest advantage comes from our extensive market experience. Co-founders Paul and myself have worked on a number of EU-funded projects which have looked specifically at taking agricultural technologies from research to commercialization, and our scientific advisor Peter has worked in the coffee industry for over 40 years and has strong connections to a number of potential partners. In addition to this, we belong to the Climate Kick Accelerator. We were national finalists of the Shiva Shrigal venture, and Paul and I were jointly awarded Young Development Agriculturist of the Year by the Tropical Agriculture Association. So, what next? Well, the money from Programmable will enable us to user test our first 150 products in the field in Tanzania. And with the help of Programmable, we will be able to create the world's largest agricultural knowledge platform to enable farmers not only to survive the impacts of climate change, but to thrive. Let's go from this to this. Thank you. Oh, yeah. So this is the rest of my team. This is Paul and Gabriel, so co-founder and designer.
Could you say a little bit more about how you're going to use the cooperative network to get to critical mass and why that's the right choice? And also why smallholders are your target market?
So in terms of the cooperatives, they have so much expertise, and what we want to do is augment that system. So we're working with Fairtrade International, who have high-level cooperatives contacting 500,000 farmers within Central America and Africa. That allows us to use the technicians to help interpret the data for the farmers themselves, but also provide things like repairs and to be able to actually advertise and sell the product to more farmers within that region. Smallholders, they produce around 70% of the world's food. We're an absolutely huge market, and yet there's a huge lack of innovation. So there's a massive opportunity to create huge impact within that realm.
How are you sending the data back from the weather station to sort of your central database?
We're integrating a GPRS module, so we're making use of GCSM, the mobile network basically, and sending, they're very small data packages that we send via the mobile network to our servers, and then visualize them and relay that information back to the farmers.
And how much does using that mobile network cost you?
For the details, we still need to figure that out. In terms of feasibility tests, we will be running, we're currently producing a PCB which has an integrated GPRS module, and we'll be running tests on the actual feasibility in probably a few weeks' time.
So considering the low cost of the device, have you thought about the margin you're hoping to achieve once you launch?
That's actually why we want to go for the subscription model, because it first of all breaks up the cost over time, but if you can retain customers on the system, then actually we make more money in the long run. So if you can retain a customer for the lifetime of the device, which could be 3 to 5 years, then you expect to make more profit for ourselves. It's just spread over the time period rather than having to make it in a single payment in the beginning.
Thanks a lot. Round of applause. Okay, up next we have Vishnu Menon with UTP.
Good evening. A few months ago, my friends and I, we started looking for a house for next year. And naturally, we went to the general commercial listings and property listings such as these. And immediately we faced a lot of problems. Firstly, the quality of properties available for students were really bad. And on top of that, we couldn't really make sure that the properties are still available for rent. And when we actually go for a viewing, rarely the reality matches the description. And finally, when we fix the property that we want to rent, we have to begin with the whole headache of coordinating contracts and payments with our housing group. So we thought there must be a better way. So we started talking to landlords. In fact, we talked to about 400 landlords, and we tried to figure out some of the problems they're facing. Firstly, we figured that they're all trying to minimize the time and effort required to look for tenants and vet for them. And at the same time, they had to deal with this perception that students are a very risky group of tenants. But at the end of the day, one thing was clear. They all wanted to maximize the yield and minimize the number of days their properties were empty. And at the same time, it's also a shame that they're missing out on a £2.2 billion market in London. So in order to successfully match supply and demand in this market, we figured that we have to really solve the issue of transparency. And while doing so, we also have to streamline and simplify a lot of these complex processes. Hence, we built UTP. So UTP is an end-to-end solution for a student housing market. So students, they come onto the platform and find a property that matches their needs. At the same time, they're also able to request viewings on the site, and once they are ready, they can apply for the property by uploading the documents and completing their profile. So for the landlord, UTP provides them with a community of verified students. At the same time, profiling tools for them to find the right tenant for them. So now landlords who have previously perceived students as a risky group can now have the tools to evaluate the risk properly and successfully enter the market. At the same time, now students are a much easier group to rent to as compared to families, and this with a better yield. So our pricing model consists of two parts. So firstly, on the student side, we're doing a 2% commission model on the rent processed, and this will cover sufficiently our operational costs. At the same time, we are also aiming to work with affiliate partners on housing-related and student-related services. On the landlord side, we have inbuilt a freemium model on the listing. And down the road, we are working with an insurance company to provide a bespoke insurance product for our user base. So by June 2018, we plan to have 1,000 rented properties with 2,500 students paying rent. And this estimates to around £1.8 million of rent processed through our platform. We have made tremendous progress over the last few weeks. We have onboarded 100 landlords to our platform at a 25% conversion rate. So we started our project in March, and since then we've been iterating rapidly through multiple MVPs and validating a lot of our assumptions. And in May, we launched our roommate matching bot to aid our marketing campaigns. And I'm really glad to say that in a few days, we'll be doing a full launch to students, and we're on track to delivering our payments and contracts product by the end of summer. So as such, we'll be spending about 40% on the money that is coming from Programmable to further develop the products for over summer, and also 20% on targeted digital marketing, 20% on campus ambassador programs. And yeah, and lastly, my mom says that great things start from home. So what UTP is doing is we are providing a tool for students to find their perfect home. Thank you.
My question is about competition, really. There's some fairly big players out there, and if they saw or see a market opportunity, they can respond very quickly without making huge adjustments to their own platforms. I just wonder how you're going to respond to that.
Right. So right now, in terms of competition, there are these big players like Zoopla and Rightmove. But the problem is because they're so big, they're not really able to move and kind of change their products to really target the student market that we are trying to reach. So in terms of the offerings, in terms of really understanding the core problems like transparency of information between tenants and landlords, and trying to really bridge some of the misunderstanding. I think the big players are really not in the right position to make the change. So that is really our key differentiation when it comes to dealing with the big players.
You have a marketplace. You've got students on one side, landlords on the other. You need to balance that marketplace. What do you think the ratio you need of students who come on and use your site to landlords?
Yeah. So the ratio we're looking at is about 10:1. So we need 10 students to around one listing.
So at the moment, is it harder for you to get 10 students or one landlord?
So at the moment, we have figured that targeting the supply side is the right way to go, because it's about we have to get the landlords on the platform first before we can tell the students, get the students on board. And so far we have figured that the product we have is kind of like fits with the expectations of the landlords from our previous testing. And so going ahead, I think we have kind of figured supply side. I think in terms of demand side, we have also gotten really good feedback from students. So I think it's going to be fine going forward with our current strategies. Yeah.
Why on earth aren't you charging landlords when they're the ones that are going to make money out of this?
True. So the thing is, there are models in our business model. We do have the part for the landlord. So in terms of rent guarantee, which is the insurance product we're releasing later on after summer. But at the same time, there is also substantial benefit that students getting out of this. So in terms of the convenience of paying rent online, and also having a verified community of listings. So I think we have tested with students, and they are willing to pay this 2%, which comes up to like a meal every month. Yeah. Thank you. Thank you.
Okay, up next, Bob Kowalski with logic-based smart contracts.
Okay, I'm afraid we have to see if my computer works here. 3, 2. Slideshow.
Do you want to switch this on then instead?
Okay. Ready? Here we go. Okay. No thanks. Right, so I'm here to talk about logic-based smart contracts. This comes from some work we've been doing over 50 years or more, which was most recently supported by Imperial College to teach logic and computing to children. As a result of developing motivating examples for teaching logic and computing to children, we realized that there were some very exciting and very interesting commercial prospects as well. So a smart contract is a computer application that represents, monitors, and enforces contracts, like between students and landlords, for example. So what's the problem? The problem is that we have all kinds of languages in computing, so how do you implement a smart contract? Well, typically you would use an imperative programming language, machine-oriented and efficient. But you might want to understand what that program is doing, in which case you have to use a declarative language to specify what the program is doing, to understand and interact with the specification, and they're inefficient. And so the usual solution is to employ high-powered mathematics and computing to check models of the execution of a program, to check that what you want actually is what you get. The logic-based approach that we are offering is different. It's a declarative approach, logic-based, where programs, if you want to call them as such, can be written in a language which is virtually identical to English, and it can be also executed efficiently, cutting out the need for programming, at least in the smart contracts application. These representations consist of beliefs of an agent, which are represented as what we call logic programs, goals of an agent, which have the form of reactive rules, which I'll show you in a minute, and destructive change of state. So what are logic programs? Well, logic programs have been around, and I was involved in their their invention, shall we say, back in 1970s. They gave rise to the Japanese fifth generation project, which was the first massive project to develop artificial intelligence applications supported by parallel computer hardware, and it was a great failure. So logic programming, many of you will not have heard about, mainly because of the failure of the Japanese fifth generation project. Well, the project failed because it was ahead of its time. It was ahead of its time, and now Logic Blocks, a big company in Atlanta, Georgia, is exploiting logic programming, and so is Google with its language Verilog. But we at Imperial College, having participated in the fifth generation project and trying to understand what went wrong, have come to a different conclusion. Logic programs are great, and you'll see how wonderful they are in a minute, but they lack a very important feature, namely goals. And goals come from reactive rules of the kind involved in the production system model of human thinking. In the psychology of human thinking, the production system model has been the most influential. But in addition to that, we also have what makes programs efficient. It's not because they're imperative, it's because they have change of state. And that change of state is destructive, just as it is in the real world. So what does a logic programming or logic production system smart contract look like? It looks like goals, it looks like beliefs, and change of state. So for example, my colleague Fariba, who works with me, is a very generous person, and whenever I run out of money, whenever I need money, she will lend me or the amount I need, provided it's less than 100 bitcoins in the next state destructively generated. On the other hand, Fariba doesn't do things for free. So if Fariba transfers money to me, then I have to transfer money back to her. I get an extra day, an extra time unit, shall we say, in order to do that, but I have to pay interest, 10% interest. When does Bob need money? Bob needs money on a Friday night when he's going out partying. And how do we change state? Well, we change state by transferring money, and what does that do? It changes the amount which is in the balance of the giver and in the balance of the receiver. So these contracts are close to plain English representations of contracts. We have worked very long in the area of legal reasoning. They don't need verification because they are the contract. They can be executed directly and efficiently. They don't need to be programmed and then proved correct. They can be debugged. You can actually debug a contract, not the program, but the contract, and you can formally analyze them. Here's what our interface looks like. Had I had another minute, I would have shown you a beautiful execution of this. On one pane, we have the program. On another pane, we have the execution trace, the change of state, and we can visualize it in 2 dimensions. So what next? We have the experience. We've worked on the British Nationality Act, very famously, I must admit. Rules and exceptions, argumentation, obligations, prohibitions, and permissions. We have the software, the LPS implementation. We have a world-class team distributed around the world, and we are ready to go.
That's quite complicated. When I think of smart contracts, I think of distributed ledger. And a lot of distributed ledger is now being provided as standard platforms, like Ethereum and IBM have also got a standard platform. And as far as I understand, and I must admit I'm a bit shaky on this, it allows you to build your own smart contracts using the platform. And so what I would like to understand is, am I wrong? Does this do the same thing?
It tries to, well, it implements it in a programming language which is imperative and which needs to be proved correct. It needs to be compared with the original contract. And in fact, our implementations are the original contract simplified in plain English, in effect. So the solidify language, which Ethereum uses in particular, is it's a nice but conventional imperative language, and it's not a contract. It's an implementation of a contract, and you don't know, you can't read that, unless you're a software engineer, you can't read the contract, and even if you are a software engineer and you read the contract, you don't know whether it's doing what the people who drafted the contract wanted.
I quite like the idea that it's removing the black box from contract execution, but who exactly is the market? You mentioned it could be used for educational purposes, or is this more for lawyers to track?
The market certainly isn't education. We were able to build the platform because we had funding for education. But as a result of developing a wide range of examples, we found this one particular application example which appealed obviously to children. Okay, what's the market? So the market is any, well, it's my friend that I just met today. You know, when you write a contract between a student and a landlord, that's a contract. How do you know? I mean, I know from my own personal experience that things go wrong. And if it's implemented in Ethereum's Solidify, you don't really know whether the contract can be trusted and believed.
Okay, up next, it's Joe Schlemper with Company FX.
Okay, hi everyone. We're Company FX, and we are developing automated foreign exchange risk advisory for small, medium corporate. So it is certain to say that the UK is currently in prolonged period of political uncertainty. We all remember Brexit referendum, which happened almost a year ago. We saw 10% drop in sterling. If you're an import company, it means that the cost of your business suddenly increased by 10%, which is a tremendous impact on the profit. And following the voting last week, we're now entering unknown territory. So the Deloitte survey reveals that now foreign exchange risk management is top priority for corporate treasuries, and 50% of SMEs are concerned of such volatility to their business. So the current landscape is as follows. If you're a large corporate, then they follow what we call advisory-based model, where they call investment bank, which will provide a bespoke solution based on your cash flow profile for free and profit on the spread of the execution. The problem with this is scalability. Because of the manpower involved, each ticket size needs to be huge, which is order of 1 million. This is not something small corporate can always offer, which means if you're a small corporate, then they follow what we call execution-based model, where they can only request the execution to their local commercial bank. And what is missing is the advisory. Another problem is that even if this advisory model is scalable, basically there's higher chance of legal risk involved on both ends, such as mis-selling. So our key insight is that this advisory aspect is, although complicated, is something we can automate. And large investment bank doesn't have the incentive to help small corporates because it's not revenue generating for them. So this is what we aim to do. We commoditize the expertise traditionally only available to large corporate and offer it to SMEs for cheap price. We are developing an automated platform which is bespoke, which provides bespoke impartial hedging strategies, which they can use in their current execution-based model. So this is the working prototype that we already deployed on the cloud. So the treasury can construct their portfolio based on the cash flow profile, select strategies they would like to try. What we provide is optimal hedging ratio for each currency they entered. Based on the feedback we receive from the potential client, we also added the performance backtesting. Even better, from the dialogues we had with our clients, the key insight we receive is that most of these small corporates use online accounting platforms, where Xero being the dominant player in the market, and we integrate their public API into our platform, which means that it takes zero overhead for small corps to use our product because we can directly import data from them. So our market research revealed that there's about 1 million SMEs in the UK alone with the foreign exchange exposure. We are offering our product for subscription-based system, charging £10 a month. We aim to get 1,000 accounts in the first year, which will generate 120K revenue in the first year. Note that we were motivated from the Brexit and British economy, but there's nothing stopping us from extending globally. With the 10K fund from Programmable, we would like to use it for ads to reach out to more clients. We're also in early stage discussion with eBury, which is a liquidity provider for licensing our technology. So our goal is to democratize the FX market and help small corporate compete with the large corporates who got more resources. So finally, why us? We are a team of unique experience and connection. So combined, we probably have 20 years of experience in finance and software. Currently, there's a huge gap in the market. There are many products which offer data analytics and accounting, but there's actually none on advisory aspect. And this is because it takes experience and insight to market to be able to be on advisory side, as well as the technological proficiency to execute your software and implementation. And this is something unique that Company FX offers. Thank you.
How do you plan to be able to demonstrate the value of your product to any client?
Yes, so that's why our priority is to So our priority is to get clients that will be on board with us, so we can develop with them and then cater what are the needs with them. And then also, in terms of showing the effectiveness, we can always use the historical data for simulation as well, but we can work with them to see if they would like to be on board or not.
I didn't really catch whether you were using anything like machine learning or artificial intelligence.
Yes, so actually most of the advisory part is not machine learning, it's more fundamental optimization and Monte Carlo simulation. So it's the basics formulation, but we are also considering using our expertise of machine learning to make better prediction in future, but that's future consideration.
Have you thought about getting a few clients on board super early where you're not charging so that you can sort of have a track record?
Yes, exactly. So that's what we would like to do, but it's quite difficult to actually reach out the clients at this point. So that's why our first stage was to get the prototype, and then now we're gonna go talk to clients. And then there's also FinTech showcase early July, which we're planning to attend and reach out for the potential investors as well.
Okay, so up next, it's Stefano Seferiu with FaceSoft.
Hello, everybody. My name is Stefano Zafiriou, and I'm here representing FaceSoft, which comprises currently of myself, Alan Ponia, who is a plastic surgeon, and my student, PhD student, Grigoris Chrysos. So we believe we found an opportunity, a huge opportunity. Currently, the technology regarding 3D phase reconstruction that exists is inaccurate, unrealistic, and inefficient. But why do we need 3D phase reconstruction in the first place? There are unimaginable number actually of applications. One actually of the applications we're currently investigating is face recognition. The majority of the mugshots that the police in badges you get is looking like this. So frontal face, good illuminated, without majority of case and expression. But when the person is going to be verified or the person is going to be recognized, you get something like that. So totally different profile views, and even the best face recognition algorithms still fail on this kind of queries. So we are leaders in 3D face reconstruction, and with 3D face reconstruction, we can create arbitrary views from a single image. So we can reconstruct the facial geometry of this person, and we can render various views of this particular face. Where is the state of the art currently? So this is a 2D facial image of a child. This is the reconstruction we do, the reconstruction we do for this child using our methodologies, and this is the current state of the art. Why? Because they do not, they lack the data. They lack the amount of data to reconstruct properly faces of various age groups, as well as ethnicities, gender, and so on. With our models, not only we can render different poses, but also we can create different expressions that can be used in many different applications, including face recognition. Also, our technology can be used for tracking even in very low resolution. For example, here, which the video doesn't play properly now, even in very low resolution, you can do 3D face reconstruction. So, what I'm proposing is to build new technologies regarding 3D facial modeling based on our large-scale database that we have collected on high-resolution 3D faces, comprising of various age groups, ethnicities, gender, and so forth, so on, which can be applied directly to 2D facial images without need to have any special equipment like commodity depth cameras like Kinect or this kind of equipment. Where are we now? We have the most extensive database of facial scans in high resolution, more than 15,000 people in various expressions, identities, ethnicities, and age groups. This database, these models have been showcased in Science as well as Times, and was the headline of Imperial for a couple of days, 2 weeks ago. So we have cutting-edge expertise. We are experts in deep learning. My lab is one of the experts, worldwide experts in deep learning for deformable models. We have expert programmers. I'm one of the expert programmers, as well as my student, Grigoris Chrysos. And we wanted to also have anatomically correct faces. That's why one of our founders is a plastic surgeon. And the business model currently we're investigating is based on security. So security is a really huge, sorry, something is wrong with this one, or I'm pressing something wrong. So security is a huge industry. Around 25 billion euros services only in UK. And biometrics, which is particular face recognition, is going to grow in 67 million in the next 10 years, especially with the current need for better security with the terrorist attacks. So currently we negotiate huge contracts with Intel and for security, and P&G. P&G is a different application. They want to have person-specific beauty masks, which can be reconstructed very easily. We have unique data, we have unique expertise. We are really ahead of the curve, like 10 years beyond everybody else in the field. And currently the money we're going to get, if we're going to get the money, today we're going to be using it for some servers and to build a mobile app to demonstrate our technology. Thank you very much.
Yeah, thanks for that. That was really interesting. I just have one question about protectability of the innovation. So it's a very hot space, especially machine learning around facial recognition, but is it just the database that is actually the key differentiator that you can train and test off 15,000? And if that's the case, then what, again, what's stopping someone else from building that database?
Yes, that's a very good question. So it's not only data. First of all, let me tell you something regarding deep learning, for example. Deep learning currently is available to everybody. You can download TensorFlow, and you can play with that. You can learn it even in a week. Data is the most important thing. But nevertheless, we build deep learning technologies tailored for deformable models. It's totally different than everybody else does. So it has to take into the geometry. It has to take only, it's not a blind convolution, deconvolution. It has to take also the information about how a face is. And this is very, very well protected, can be very well protected as patents in FaceSoft. FaceSoft as well, I mean, we not only to provide all the information for this particular, but it's not just blind deep learning, you download TensorFlow and you play with that. But also, just to continue that, collecting 15,000 faces in high resolution, it's a multi-million dollar project.
I was just wondering why you would do a mobile app, because I mean normally mobile apps are only useful when you're going to when it's a consumer that's going to use it every day. It's not really what you're developing is core technology that can be delivered through other people's systems like Google or whatever. I can't see myself opening up an app to access this service.
So, for example, if you really, I mean, when we try to make a case for our company, one of the first applications we have in mind was beautification. Would you like to see your face beautified? You won't. I can do that. You want to see your face aged, more aged? You won't. You will download it to do that. You play with Snapchat all the time. You do. I mean, the majority of the people do that. And they have much more, less complicated filters and much less realistic filters. You're going to do that. Currently, a very premature app is thriving who just sums an aged person with you, and they get like thousands of downloads. So you're going to do that, I guarantee you.
Okay. Yeah, thanks.
All right. Now it's Phil Sandwell with Clover.
Hi everyone, my name is Phil Sandwell. I'm here to introduce to you Clover, but before I do, I'd like to introduce something else, if this is working. Sorry. Yeah, I'd like to introduce Clover, but before I do, I'd like to introduce someone else. This man is called Hari Ram Arya, and when I met him 2 weeks ago, he was one of around about 1 billion people around the world that don't have access to electricity. This is him in front of his house, and in front of his family, and in front of his 2 cows, his most prized possessions. And when I met him, he relied on kerosene for lighting, which is incredibly expensive, it's incredibly polluting, and it's incredibly dangerous to human health. And this is what he and his family would sit in front of every night in order to spend time together. Some other people in his village would have electric lights, like you can see behind me, but it's not much better. A few people would have small solar home systems that could maybe power one or 2 bulbs, maybe charge their phones, but nothing else. And then on the outskirts of the village, they had grid wires, but no power had ever flowed through those, and realistically, it was never going to. So how do you solve a problem like rural electricity access in the face of these challenges? And one way to do it is through renewable energy mini-grids. So these are small, community-scale energy systems that can provide sustainable and affordable power to a community, to a village in the remote and rural areas of the world. But they do have their problems. They're quite easy to design, but they're quite hard to design well. And it means what's happening now is that people will design systems that are way too big to ensure that a community has reliable power, but it means the one next door doesn't have any power for the next 1 to 5 years, which is a huge problem. And this is where Clover comes in. So the idea is that this is a tool to simulate and optimize mini-grid systems so that they're appropriately sized for a community, and it means that we can reach these 1 billion people without access to electricity much faster. Sustainable Energy for All, which is a UN body, says that the scale of this problem is $45 billion by 2030, of around maybe 10-20% have actually been committed. This is a huge problem. There isn't enough funds, and we need to do things faster and do things better. We can provide energy demand assessment, predictions, growth assessment as people get access to more electricity, also business model analysis to new companies that are springing up trying to solve this challenge. And this is designed for and by mini-grid developers to make sure it's fit for purpose. A mini-grid developer will go into the system, they'll choose their location and the power sources available to them. In this case, we've selected solar PV and battery storage, which is pretty common across the world. And then they'll select which devices they're going to sell to their community, which one's going to be used. From there, we can simulate the system over however long they want to, a number of years, and get the performance, the recommendations, and the impact that has on people's lives. We can also re-optimize the system over time as demand increases. As people get access to electricity, they want more and more and more. They get lights, they want phone charging, they want TVs, they want refrigerators. And this is a problem that's growing and growing and growing, and people want to make money out of this, but quite frankly, they don't know how to design the systems to do that efficiently and effectively, and that's where we come in. We focus on the service of energy provision. I don't know how many kilowatt hours of electricity I use every day, and nor do the people using these systems, but they know that they want light when it's dark for 8 hours a day. We can do hybrid generation analysis. If you have a system that's not running very well, we can suggest other technologies to integrate into that in order to make it better and provide a better service to your consumers in the developing world. We can also provide long-term growth. Energy demand increases, you need to build a bigger system. And mini-grids are perfect for modular growth. Add more solar panels, add more batteries, as people want more and more and more power. And also we have this intuitive scenario analysis. What if I did this? What if I did that? What if I built a really big system on day one? Or what if I came back in 6 months' time and added a few more panels, which is more cost-effective to me as a business, which will allow me to grow my business faster? These are the questions that we can answer. There are other competitors on the market across a wide scale. One is called Homer. It's very high-end software, and it's very complicated, and realistically it's not being used as much as it should because it's too expensive and it's too complicated. At the other end of the scale is things that are too simple, like this company called ESCObox, which is insufficient for making any kind of business analysis decisions. We've already had different case studies. In India, we've quantified the impact of different mini-grid systems. In Nepal, we've increased revenue by suggesting new power sources for communities. In Rwanda, we've reduced costs by suggesting different business models for companies delivering these systems. And these are some of the partners that we've already worked with and are interested in working with us more. So the next steps is the problem right now is that our software looks like the top, which is a power connection box being worked on by a technician. You need to really know your way around these things in order to get the most out of it. And what we need is something on the bottom, something so easy that even a child could use. So from the academic to the commercial transition, what we need to do is build a usable user interface to integrate all the needs of the consumers or the mini-grid developers in order to use the system intuitively and use it to its full potential. And then from then on, we'll identify initial partners around the developing world, of which we already had several, to roll out the first kind of beta testing. So I'm really happy to say Harry Ram now actually does have power. I was there when his lights got switched on, and he was incredibly proud of the fact that he was the first in his family to ever have electrical power. And this is him with his son, and he'll be the first generation to actually be able to study using electric lights. He was incredibly proud of that fact, and it really warms your heart. Now he spends roughly half as much as he used to on kerosene on mini-grid electricity. And it's going to be better for him, better for his children, and better for the future of their village. But there's still hundreds of thousands of villages to go. And quite frankly, we're not doing it fast enough. And this is where Clover comes in. So we want to help light up the world, one village at a time. Thank you.
Aren't the mini-grid providers providing only one solution at a time? So meaning that this solution, would it be more applicable for more like councils or governments compared to actual mini-grid providers?
So I think in terms of the customer segments, I think it can be quite diverse. So mini-grid developers, they know how to do their business, which is sell electricity. Generally, they don't really know how to design systems well. So they need to know how to design systems efficiently. There's another market, which would be the NGOs and the government bodies. So I've spoken with some, for example, in Nepal, that were very keen to basically get their hands on my software. They had some training with this Homer software, and they said, oh, no, it's too confusing. It's not fit for purpose. But they, as a government body, want to use this software so they can design case study systems that can then be used as examples around the rest of Nepal, but also do like scenario analysis. So like what happens if we promote solar, which isn't very common in Nepal, ahead of hydro, which is already really common? What happens if we use different energy technologies? What will the cost of that be? What will the greenhouse gas implications of that be? So government bodies are interested too. Some of the other work that I've done using this software actually is with an NGO, a US-based NGO that's interested in the climate impact of mini-grids in India. Because they want to know, if you install thousands of mini-grids around India, what's the climate impact of that? So it's a really diverse range of people that could be using this software. And the important thing is that it's intuitive for all of those different people to get the impact, like the key performance indicators out of that they need.
How do you get the data about the local environment and sort of like the population and whatever else you need to actually do this analysis?
Yeah. Okay, so there's two answers to that. Personally, I go there and ask people questions. That's what I was doing with Harry Ram and his friends in the village. But quite frankly, I'm not in the business of telling mini-grid developers what their business is. But every mini-grid developer will have a growth strategy, and they will say, by day one, I want to have like 20 households signed up on this package, which will be lights, phone charging, something like that. By the end of the first month, I want a couple of people to have fans. By the end of 6 months, I want people to have TVs. Like they have the growth strategies, which can be directly implemented into this tool. Like I'm not in the business of telling them how to run their business, but I can provide the tool for them to put the numbers in and tell them what the impact of that will be.
Also, sorry. Following on from Nick's question, it's quite related to that, but because I faced a very similar challenge in my PhD thesis, I used Homer. I also used the solver function in Excel, and I don't think even a middle ground between them would have solved a problem that we had more fundamentally around predicting demand when there's no historical data.
Mm-hmm.
So in terms of the optimization that you're offering the microgrid provider,
Mm-hmm.
How would you overcome that problem? Is it about integrating early on and learning with them, or and helping to other clients from that data, or how do you solve that problem?
Yeah, I would say, of course, there's learning that can be taken from different operators. Like the mini-grid community is incredibly collaborative across the world, even within the same country. Like people competing with each other are actually very helpful with each other. What I would say there is that the scenario analysis that this tool can do can help assess what the impact of different like uptakes of technology or uptakes of devices or whatever people have access to would be. So if you think, okay, well, we're going to go in and everyone's going to sign up on day one, we can analyze that and what we would need to do there. You can do a sensitivity analysis and say, okay, well, what happens if half as many people sign up, twice as many people sign up? Like that's the kind of input that you can put into this tool to show like what the impact of different scenarios will be, and then from there you can make a business decision from that. Thank you.
Okay. Up next is Margarita Komnitsky with Izzy.
Thank you. Hey. Good evening, everyone. My name is Margarita, and I've named my software project after my cousin Izzy, and I'll show you how it makes lab automation easy. I'm sure you all know the frustration of doing an annoyingly repetitive task like clicking through an Excel or washing the dishes. And for a biologist like me, that usually involves pipetting tiny amounts of transparent liquids from one tube to the next over and over again. So that's when you find yourself asking the question of why do you have to do this? Why is a robot not doing this kind of task for you? So thank God, liquid handling technologies have come a long way. So there's not just the good old micropipette, but there is electronic ones and multi-channel ones and automated platforms that are kind of cool. But what's even cooler are those machines that use sound waves to transfer tiny droplets with an incredible speed and very precise accuracy. So this is kind of how many liquid transfers per month I've been doing throughout most of my PhD, and that's the time around October when I started using one of these machines. I'm working on a new synthetic biology method that I wanted to automate, so I was really excited about getting access to one of these machines, but then I had to face the reality that it's pretty hard to automate a new kind of experimental procedure with one of these. Unfortunately, the text is missing. But one of the problems is that you have to integrate three key aspects with the software, not just the hardware, but also the wetware. And also the current software that comes with default with the machine that I'm working with takes in a set of instructions and form of a list for the liquid transfer steps. So using that default interface, we're back to something that consists of just clicking through Excel. So in order to solve that problem, we would need a custom code that takes high-level parameters, such as the samples we have and the replicates we want, that would generate instructions for the machine and also for the biologist. So then I learned how to code, and I wrote some bunch of code for myself that would do these tasks, and I'm using it to develop gene therapy kind of synthetic biology tools that could be used for cancer or curing cancer or genetic diseases. And some of my colleagues work on similar methods than I do in biosensors or metabolic engineering, but they don't know how to code, and most of the biologists don't really know how to code, and we wouldn't be able to use my automation workflow as it is at the moment. So that's when I started working on a web-based application where you can have a plan section and enter the experimental parameters into a form online. And when you click submit, it generates files both with the machine instructions that you can download and the instructions for the biologist. And I would really like to now take this web application forward and complete it as a finished product. So what are the commercial applications for something like this? The lab automation market is estimated to be about 4 billion and to double in the next 10 years. The software is just one segment of that, and the hardware for liquid handling technologies is the largest segment. The lab site, which is a company that makes the machine that I am working with, made 18 million in sales, and I just got a number for them. From them, they have 150 of these machines just in the UK. The users will be diverse. For biotech and pharma, with hospitals and private labs, we could offer subscriptions, and then also consultancy if they needed new kinds of software that would add to our know-how as well as revenue. For academia and research institutions, and also we could partner with the hardware companies for full automation solutions. For academia, we would offer free accounts and also form partnerships for developing new software. Synthetic biology could be is a niche for us within the lab automation market because it's a growing part and it is also my area of expertise. And with the proof of concept funding, I could take a bunch of code that I'm going to reference in my PhD thesis in the methods section and turn it into a software usable for biologists. I'm counting on the continued support of my advisors, Dave, the head of automation at the London DNA Foundry, and my PhD supervisor, Paul. And I am looking for team members, so please come and talk to me if you're just as keen on making lab automation easy.
My question is, how standard are the sets of information that you have to deliver to the machines, in other words, for different manufacturers and things like that? Because at the moment, I think you're just working with one manufacturer.
Yeah.
Do they have APIs and stuff like that, or probably not?
So the way that works is that this is the specific machine that I'm looking at. There is one software that takes a file with the CSV file with a set of instructions, so that's kind of the interface to communicate with it. I don't know about APIs are being developed for the tip-based liquid handling platforms, and there are some companies working on that. But for this acoustic platform that I am working with, the interface is the CSV file.
What did GSK do?
Okay, what they would do is...
What do they do at the moment to solve this problem?
I think they develop their customizations for the software in-house. So they could use us as a consultancy.
Quick question, so are you doing anything clever around, you mentioned you could take effectively the method section from your thesis.
Yeah.
Are you doing anything clever in terms of sort of scraping research papers to try to sort of crowdsource those, the process or the protocol?
Yeah, so it is currently kind of a limitation in lab automation that the way that the protocols and the instructions are defined are very different. And there is a big effort in the community to kind of build up a formalized language of how we encode this weird mix of machine instructions and like manual instructions for what to do for the biologist. So it's a big challenge, and I think my software could be part of solving that, at least for some applications.
Okay, now it's Hanyap. with Hugo.
Hello, today I'm presenting to you Hugo. Transport and commuting is basically a large part of our daily lives. For us, it looks like this, but for people in wheelchair and mobility impaired, they have reduced choices and reduced access. And it is a problem that affects close to 1 million people in London alone. Well, any other existing technology, given that we live in a technological era, well, in fact, just too many of them. Looking at any kind of like mobility impaired user's phone, you will see that there's one application for one purpose. Well, we think since so many technological apps out there, how does it help with their daily lives? Well, this is a journey from Westminster to King's Cross. Using TfL, it shows that we can go through Greens Park, and it seems all plans settled. Just stopping at Green Park, you found that your lift is broken, you can't get to the transit, you have to turn around, adding a lot of stress, time, finding alternative solutions. Well, not only that, you also run late to other appointments, meeting other people. That really puts you on a very, very bad day. And not that, it's 60% of people claiming that they don't enjoy going out. What is there for Hugo and how can we help? We are creating an on-the-go solution so that you can have instant access wherever you are, giving you choices, not just one, but more than one, what suits you the best. Other than that, we are creating a community to tell you what are the problems on the road. For example, in this case, the pavement is blocked by a temporary construction. Flag it up, other people, we can use that useful data to avoid problems and make it much more stressless for other people. On the roads, on the streets as well, shops is the ultimate experience where you enjoy the day. Knowing that there's very, very little wheelchair access places, users have told us that given that if we can tackle one small steps or maybe some few small steps, the options to them is really, really tremendously open up. So, given all these options and all this improvement to life possibility, what are the business models that we could explore? We are not too sure, but we can say that, okay, maybe we can ask people to download and pay for it. Or maybe because the ability of Hugo to accumulate users all together in one place, imagine this 1 million users, we can create a marketplace where business create tailored services for them. More interesting for us is the data and API that we can work with this specific users group. Potential partnership, for example, banking, hospitality, insurance, airlines, or even if you're council trying to find which pavement you want to improve, we can help you to provide that information. Why this uncertainty behind the business model? Is because users is very important to us. Do we get this, or this sheer amount? Ultimately, we are really targeting a service that can improve lives, not only in London, but globally. We need the help. So where is Hugo now? We have been improving our business and improving our presence in Mayor London competitions. Now we are trying to develop, using what we know, we are trying to develop a prototype using hopefully with some ventures money, if possibly targeted. Then we would really like to run a trial, a small-scale trial in the summer months. With a successful product, we want to pitch for more because we really understand that the scale is an ability for us to succeed. Today we are asking for £10,000 to prove our concept, to prove our trial. Other than that, we are also looking for talents, people who know how to code for map, user interface, the very back-end infrastructure. Please contact me if you're interested. One and the only objective for Hugo is really to improve convenience for the ones who need it the most. One day we want to be proud of ourselves and say, Google Maps for wheelchair users is finally here. Questions?
I love crowdsourcing transport data and Waze do it really well. Waze though have roads and cars and I guess bikes as well. You have undergrounds, pathways, parks, etc., and you have wheelchair users or someone in crutches, how do you go about tackling the far greater complexity that you have compared to, say, a Waze?
Yeah. Actually, not only that, just to add to the complexity, people with breathing problem as well, they find that if I can walk few steps, you can see that the scale is very, very big here. So what are we trying to do is actually understand how do we parameterize physical constraints. For example, we are talking about door width that's limiting people, steps height, gradient, different type of road surfaces. So this kind of like physical parameters, how do we transfer real life into a physical kind of like numerical parameter is something that we have to work with users probably in the trial period where we develop a prototype solution and then ask users to feedback and help us where we can help them to make the world even more presentable in an app form.
So how do you access these users? Are there like groups that are kind of, particular for mobility
There are
impaired?
two current methods that we are considering. One is through, for example, I showed earlier, some charities. There are a few big charities headquarters in London where we are trying to engage starting from July and see how the discussion goes on. But knowing that some people, business mentors have told us that the engagement with big charities is very difficult. So another possible solution for us is actually going through the social media where we have to target each individual users independently. Any last questions? Thank you.
Now, Hugh Evra with Graphics Fuzz.
Thank you. All right. Hi, everyone. I'm the second to last, so please don't fall asleep, and I'm going to keep you awake. So my name is Hugh Evra. I'm currently a postdoc researcher in the multi-core programming group here at Imperial College. And I'm really excited to present you Graphics Fuzz, which will fix graphics drivers to secure billions of devices. Many applications rely on a graphics processor for their image rendering. This was pioneered by video games, but nowadays you have a dedicated graphics processor in almost all devices, including laptops, smartphones, and even the latest cars. This is to support new and exciting applications such as virtual reality, rich web applications such as 3D maps, but also more safety-critical applications like self-driving cars and medical imaging. Now, all these applications rely on a graphics processor, but what if the graphics processor is unreliable? What if you expect this image on the left, but you get this garbage rendering on your right? Or what if you don't get an image at all, your device just crashes? Or what if we could, using a simple web page, exploit a graphic bug to actually capture the image rendering of another tab of your browser, including sensitive data like your bank account, and upload it to a remote server? Now, these three issues are actually real examples that we found in our research, and the issue resides in defective graphics drivers, which is the low-level critical software that communicates with the graphics processor. How bad is this issue? Well, security vulnerabilities damage company reputation, and it's bad enough that Apple offers you up to $200,000 for a bug that is related to security. Now, these companies are putting a lot of effort for robust graphic drivers. They are paying entire teams of expensive developers. But these developers are struggling because they are facing a never-ending work to handle new hardware as new graphics processors are released on a yearly basis. And in this domain, bug fixing is extremely time-consuming, and it's common to spend days and even weeks of developers' time to fix such issues. Now, our solution, Graphics Fuzz, is a tool that finds bugs in graphics drivers automatically and creates guided bug reports for developers. Finding bugs before the release of a driver is a critical feature in order to keep the device secure and to save the company reputation. Now, finding bugs automatically, and for each of these bugs, create a guided bug report that lets the developers isolate the root cause of the bug, saves tremendous amount of developer hours. And this tool works. In a couple of months, we were able to report more than 70 bugs across all 7 of the main graphics processor designers. These are the main graphical processor designers. by reporting bugs to them, we catch their attention. And I actually went to the US to meet most of them in their headquarters and meeting the technical teams. And I've presented slides, and they do see interest. They see immediate benefits in fixing their drivers because they are telling us they are struggling to get them right, to keep them secure. Now, while on the US, I also went to talk to another few companies, including Google and Microsoft. And we were actually surprised that they do seem interested by what we are doing. And why is it so? Well, these companies have products like operating systems and web browsers. And they want, at all costs, they want this product to remain secure. But they do not control on which device they are run, so they have to impose some kind of quality to this device. And to doing that, they are imposing huge compliance test suite. And a graphics processor designer has to go through this test suite in order to be validated as an official product. Now they see great value in graphics first to augment this test suite. To wrap up, our business model is the following. The customers are graphics processor designers companies and tech giants like Google and Microsoft. They will pay for automated testing and guided bug reports. But this is the printer part of our product. What is the cartridge? What is the thing that we can keep on selling? This is test suites, and we can release new test suites, say, every 6 months and make them pay for this. The critical intellectual property is test generator tool. This is very hard to reproduce, and this is closed sourced. An overview of the team. I am the entrepreneurial lead, and I established the contact with the customers. The group leader, Alastair, is dedicated to this project, and Alex is instrumental in business advising and technology transfer. Now, we are committed to push this forward, but in order to take the project to the next steps, we do need additional developers. Speaking of next steps, we spoke with the customers, and they actually want to try the thing, and we are now signing NDAs with them. They also invite us to focus on security, to extend it to cope with more drivers. Now, we need resources to pay developers to make this happen. We need resources to fix graphics drivers and to secure billions of devices. Thank you very much.
Do you need to customize every time your solution to apply it to different chips?
No, because we are facing the drivers, we are facing an interface. There are a few interfaces, not much of them. We focused on the most portable one, which is called OpenGL. This is the one that was used for most video games so far. This one is usable on Linux, Windows, macOS. Now, the few ones that I mentioned here, Vulkan is the OpenGL ++, let's say, is the next version. And DirectX is a Microsoft-specific thing, and Metal is an Apple-specific thing. So we will need some more, effort to cover this interface, but these interfaces are independent for the actual chip that is besides, and because we are targeting the software that is that is sitting between the interface and the actual hardware. So to wrap up, our project is not dependent on a particular chip, no.
Is some of the technology patentable, or can you protect the IP?
Speaking of reproduction of the technology, right? So it's not patented yet. We have actually published about it. It's out of a research project, so it's already in the known. I mean, in the wild. Now, this is what it looks like actually. You can see that we take some graphics workloads and we create variants that should render the same image. You can see you can have some bad image renderings and some crash and some other things, and these are results on the Galaxy phones, for instance. And what I want to say is that in order to obtain these variants, you need to apply semantics preserving transformation to graphics workloads. This is deep expertise compiler technology, and thanks to the expertise we have in the group, we can achieve that. This could be reproduced maybe by companies, but to be honest, it will take them, I would say, at least a year, because we hit a lot of bumps around the road. So we think it's really it's not worth it. Basically, it's better to work with us than to try to reproduce it and not being even sure to actually manage to reach this point.
And last but not least, Murdad Babazabit with Arco.
Thank you. Hello, everybody. Good evening. My name is Mehrdad Babazadeh. I'm postdoc in computing department in Imperial College London. My software is ARCO, stands for Applied Relay Coordinator. It's in the field of power system protection. Yes, what's the protection? Protection means isolating a faulty part of a grid, big grid, and in a given time and with the minimum impact on the rest of the grid. Actually, ARCO focus on this protection among the other study field of power system analysis. And ARCO is a practical client-server based program, and it aims to give settings for protective relays and in case of fault occurrence. The history of ARCO is that it was used for the first time in 2004 by a power system industry. And in 2012, I started to make a new edition of ARCO, and it has been developing up to now. It was technically approved and registered in the meantime. This is a power system. Don't worry, I won't go to the detail. And this is just a power system that ARCO, the old version of ARCO, provided settings since 2004, and it is still working and it's alive yet. If we want to protect this big power system, we have to focus piece by piece. And if we go to part of this power system, which is a substation, we need to protect everything in this single line diagram. And if we fail to protect, this may happen. And or this one. You may enjoy of this, but people will lose the power based on that. And this may happen. And in the worst case scenario, this is the blackout that may happen. This happens in a developing country when just a very small fault occurs in a power system. There are already some software programs in the market. They have some functionalities like providing protection. They give some other functionalities like short circuit, load flow, and so on. But ARCO just focuses on protection and gives the best and the most details which is possible for protection. And we have two ways to develop this software. It can be used alone, or it can be a function of the other platforms like TickSilent and ETAP and so on. And we have two ways to go to the market. We can count on academics, and we can work through industries. We have already been in industry for 14 years. If I compare other softwares in general with ARCO, actually they offer some studies, which is good part of them, and they are known in the market, but they don't give enough detail which is really needed in protection studies, and they are quite expensive and hard to work. If you go to a market and ask what functionality do you use from these softwares, they will say just 1 or 2 from 10. And ARCO gives more practical outputs and detailed calculations, and it's cheaper and simple to work in comparison with the others. But it still needs other softwares to provide primary data. This is how ARCO looks like. And the future plan of this software is to make connection between ARCO and the other softwares, first of all, and make a connection between ARCO and relays, so that after doing calculations, we upload the settings directly to the relays who are responsible for the protection of the system. And we are going to make extra functionality to this software and make a web-based ARCO so that everybody in the connected to the net can use this software. and to change platform to Java to be used in different platforms like mobile applications and so on. Thank you very much. Yes.
Industry, are there any cases where companies of power systems have used novel technologies?
Actually, I have been a power protection engineer for 6 years. And I am familiar with many companies who are dealing with protection. Actually, all the electricity companies deal with this, which is the most important part of the maintenance of power system. But actually, they do protection like they count on the expert people more than the softwares, because the protection is, people in industry, they say that protection is the art of protection. It's not just technology. It's not like just formula that you apply everything and get response of that. That's why they use expert people. And this is the point that we have focused on that, and we offer the calculations based on exactly how expert people do, not just based on standards. We use standards, of course, but we are not stay just on the standards, and we apply expert people, expertise, and these kind of things. Yes, it is used in one company for some years, as I mentioned before, and it made a huge success for that company, which was at the end of the ranking, and it came up to the first.
Why did you not make more progress with the first iteration of your software?
Actually, it was developed several years ago, and used to be solve the problem with the simple kind of grid. And now the grid is connected, more connected. We have ring side connections that we didn't have at that time. We just had like branch type network, and it was a simple scenario for the power system. But now it's more complicated, and you have renewable energy. You have like ring. You have a mesh form of the grid, and it makes more complicated. It dictates more complicacy in the calculations. Yes. Thank you very much.
Okay, that was it. So now we're going to get the judges to, I think, go to a separate room to convene and decide on the winner. And we're going to open it up for general Q&A. So if you have any questions for any of the teams, now's the time to ask them. And we're actually going to ask all the teams to come out at the front. I really hope we get some questions, otherwise it's going to be very awkward up here. So please ask some questions. You have a question? Okay, great.
I'll start with one question. So my question is to Stefanos, I think. Yeah, I was wondering how don't you have any issue with using the database? Like how did you get the right to use this database?
So yeah, very interesting question. So all the data have been collected under the ethical approval of Imperial. Imperial allows to use whatever database you could collect, if there is an informed consent for commercial applications as well. So the people who have signed the informed consent, so give us the right to use their faces for commercial applications.
Anyone?
I was going to ask about the mini grids. So what are your plans for next steps? Like, how do you plan to use the money if you get it?
Sure. So at the moment, the software is very much an academic tool. So we've been doing plenty of academic research with it, but with commercial interests in mind. So helping the businesses, the governments that are interested in this kind of analysis, like, you know, answering the questions that they're interested in. So the next step with that is basically making it so that we can release it out into the world. So everyone using it now is academically trained with the software, but realistically that's not viable going forwards. So in order to take the next step, that's going to be packaging it into a decent user interface. Like, all the components are there, it can do everything you want to do, but you need to really understand how it works. So the key now is to basically put the buttons on and put it in a nice little package so that people that aren't experts in coding can just download it or web interface it or whatever you want to receive it, and get the full functionality out of it in that way.
I have a question for the founder of Flat Searching Platform. Sorry, I don't remember the exact name. But yeah, have you realized the existence of student.com campus room, which are targeting at international students? It's a platform to list all the available student apartments, as well as some private flats with ratings, with detailed information. It really helps solve the problem for international students.
Yeah, right. So there are these like smaller like websites with these like listings, right? So, but you know, most of them, they work off a very outdated model of operating, and so over time, as we build a community, we are very sure that we can retain and grow the community at a much better rate. So that's kind of like how we're kind of like gonna edge off these smaller players.
Okay, the student.com is its valuation is billion. It raised several rounds of money, and it's really good. I just want to know, how do you further differentiate?
Right. So like I said, so we offer all the improvements to all the process, from finding the place all the way to paying rent. So I'm not too familiar with student.com, but what we're trying to do is really like close the whole loop. So from the start, from finding place, rent, doing the contracts, all the way up to paying the rent, and then as you leave, so if you're a current tenant, you'll be incentivized to like get your juniors to rent out your place. So it's kind of like closing the loop and growing with that sort of method. So yeah, so certainly there are certainly players there, but I'm sure we can edge them off. Yeah.
Okay, thank you. Yeah, I think they are not doing this, so it's good. Yeah. Thank you.
I guess I have a group participation question. So I'm kind of new to seeing people take on so many things, and I'm kind of curious about, like, as a group, for how many of you guys was this the first time you'd sort of, I don't know, thrown your hat into the ring on something and taken something on? And for how many is this something that you felt confident doing for a while? Do you want to just do a show of hands, maybe? I mean, that might be easy as well. Like, for how many people was this like the first kind of idea that you pursued, and for how many people have you had other ideas, business ventures that have disappeared? First time, raise your hand. So quite a few. It's pretty cool. And so the rest were it. And the other question I wanted to ask, similar, is I saw some people who did this like as a research project. Can you raise your hand if this was like outside of your area of expertise, just sort of an idea that you came across? Yeah? So quite a few people are following their kind of PhD areas. Is that right? And if anyone wants to comment on that, I'm kind of curious about that distribution in general. Anyone have any?
So ours came out of our masters, and what we were doing during our masters was approaching this as a problem that you couldn't provide tailored support to millions of farmers. It cost too much and was project-based. The masters was very much conceptual, so it's how could you set up a system that would solve this? And then we started the business afterwards, which is very much practical, right? So that's, we know that you need to automate, for example, the weather collection. You need to have various partners on board. How do you actually make a business out of that? So it's two different things, and I think that's what, for myself, I find very interesting about it, is it's very easy to write a thesis for your master's, whatever, saying this would be a great system, but it's something very different to turn that into practice. So that's my personal experience of it.
I'm somewhat unique here, actually. This wasn't a research project. This actually started off, this sounds quite funny, but it was actually my A-level computing project, something very, very similar to the prototype I've shown, actually. And it's just something I've continued working on. And that actually did teach you a bit about listening to your customer, in which case that was my electronics teacher at school, and so they actually have now continued using it.
To comment on this, I would say this is kind of a funny story because we actually talked to ARM, I think, to start with. And they say, oh yeah, that looks good, and can you report a few bugs? And we said yes. And then we thought, okay, we're going to publish a paper, put the tool like open source online, and it's going to die, like most research tools. And it turned out like ARM was like, oh, but actually, yeah, it's really interesting. Could you give us more bugs, more bugs? And we're like, wait, you want it. Let's speak money, let's start to, yeah. And it was just about timing. We just got an opportunity to get some funding, so which paid for me to go to the US and meet these guys. And yeah, it was just good timing and sense of something, yeah. But there are lots of research projects that just end up being open source. You should check for them. Maybe there are good business opportunities there.
Anybody else? Was there another one from the audience? Okay. I actually have one myself, so if I may. This one's for Bob. So I just wanted to throw in one of the buzzwords out there, which is, everyone's talking about AI, artificial intelligence. And right now, as we all know, the sort of creme de la creme is what everyone's using is deep neural nets, so that's very statistics-based, artificial intelligence. But of course, you're taking a different role with the logic-based AI. And I have heard researchers working in this field saying that this may be the next wave. So maybe it's going to be the logic-based, maybe it's going to be a sort of hybrid model. I just wanted to hear some comments on that, if you think this is going to be the next thing in artificial intelligence.
Well, the big complaint with deep learning approaches, statistical-based approaches, neural network-based approaches, although they're fantastic in what they've achieved so far, is they can't explain their decisions. So if you have a self-driving car, for example, that's been trained on lots of experiences, lots of big data, when it decides to drive into a pedestrian rather than into the fire station, let's say, it can't explain why it's made that decision. So there's no doubt that the next wave is going to involve systems that can explain themselves in human-oriented terms, logical terms, and they will be compatible with deep learning systems because that's how humans work. Humans both have instinctive responses and they have contemplative, deliberative response. And I mentioned to you when we talked before, Kahneman, the psychologist and Nobel Prize winner in his very famous book, Thinking Fast and Thinking Slow, talks about the dual process model of human thinking, which involves deep learning at the lowest animal-like levels, but also contemplative monitoring of stimulus responses. Yeah, so there's no doubt that it will come. It's a question of time. The Japanese thought it would come in the 1980s, and they were wrong. And now it's coming in the 2010s, 2020, but it's coming very fast now as well.
Great.
I have a question for FX. Given the recent volatility in currency, did you use the tool to, I don't know, predict some trends or even made some money in the volatility?
Yeah, so we only started afterwards, so unfortunately no. If we had the insight before Brexit, so we came out with the project afterwards, so no, but yeah, I mean, you can. So it's more of hedging tool rather than making money. So that's where we're focused on. So yeah.
I have a question for Stefanos. I'm wondering about the accuracy of your system and how can it handle sort of facial hair changes and stuff like that.
Yeah, so regarding accuracy, so in order to test the accuracy of a system in arbitrary conditions, you need actually to also try to record, to have an actual measurement of the 3D facial structure in arbitrary conditions. So currently, if you are outside and you want to reconstruct the face, your face, for example, or even an arbitrary object, is not doable. So there is not current technology that you can use to take the ground truth in order to measure the accuracy. If you collect the data in laboratory conditions where you can have ground truth, there we can reconstruct in sub-millimeter accuracy the face. But these are not so challenging conditions. So if you are in well-lit conditions, where in front of, for example, so the current technology to reconstruct, for example, faces in high resolution where we build the models, it costs like the machine we use. We have now currently actually we're still collecting data. We're in the Science Museum in Who Am I library. You can go and check it if you like, and get your face recorded. You can get a free facial scan of your face to use it as a souvenir. So the device we're using is I think it costs around £200,000 to reconstruct the face. So in this kind of conditions, we can get sub-millimeter accuracy. But our challenge is to reconstruct faces in arbitrary conditions where there is no ground truth to tell you how accurate we're. While you hold for example, your cell phone or a child eats ice cream, how accurate we are. Nobody can. Unfortunately, we cannot.
Okay, but like, I mean, in terms of like recognizing Barack Obama and stuff like that.
Okay, so recognizing Barack Obama is a second stage. So what we do is normalize the pose, and currently the face recognition technology we offer based on normalizing of the pose. Currently, we are one of the 3 or 4 based on the standard challenge, which is testing in a huge database of millions of faces. We are the 4th without even scrapping the web. So the database, the people that currently working on that, for example, the top one is Google and Facebook. They take your face. You have to know that Google and Facebook, you give them when you enroll, you take into the Facebook, you take your face without even your consent and use it for training. So without having these large databases, we are 4th, so very, very close to accuracy, using only synthetic data from our models. If we start scrapping the web to collect data, which is something that is a practice currently applied in all face recognition, I think the accuracy will going to be even further improved. Nevertheless, the database that they're using is, again, almost frontal. Nobody dares to do this still, currently. So it's only frontal faces. So actually, we're building technology. The technology can be applied there are so many applications you cannot imagine. So you can reconstruct with a cell phone, you can reconstruct your face, and you can use it in a virtual reality world. And you can use, you can be an avatar of yourself. So there are a huge amount of applications. So now we're hitting one because when we put the technology out, so it was recently covered by Science, immediately Intel called us and they want something to improve their security, their face recognition algorithms. So we had to narrow down the application. Currently, we're doing that. And also Procter & Gamble, they wanted 3D face reconstruction to create masks, to create personalized masks of people, beauty masks. Because currently, have you used beauty mask before? No, I have. In any case, just for fun. So they come in very small amount of sizes, and they're not personalized. But with 3D printing, a new kind of 3D print, you can easily 3D print your beauty mask. Take exactly the analogy of your faces.
Yeah. So my next question is to CircuitBox. So regarding your app, would you be willing to add on buying the circuits for users if they make something that they like and stuff? Can they buy it in the app or something like that? Have you thought about that? Further development of your, I'm coming from the business school, so just to, ask about that.
It's one of those ideas that actually when I was first doing the circuit simulator and thinking about ways of monetizing it, funnily enough, I'd kind of vaguely thought about, then completely forgotten about. But it's interesting you mention it. I'd actually thought perhaps more not about selling a completed circuit, just because circuit assembly is pretty expensive, actually. It's labor intensive. It's actually a lot harder to automate than you might think on the small scale. So it would probably be more like you build up your circuit and you can order a kit of parts, say, for example. Right. You'd be talking, even for a circuit you'd think would be really simple, you'd be talking about a few £100s to have one built in single quantities, really, even with the kind of people that try and automate it. And for the people that do it manually, it's considerably more expensive than that. But Yeah,
Thank you. Can I have a quick other question for Clover? I wanted to ask you about your research in Nepal. You said that you looked at the hydropower and the solar power. What was your findings and where did you do the studies in Nepal? I'm from Nepal as well. So.
Okay, cool. Is this on? So I actually spent most of my time in Kathmandu. So unfortunately, I didn't do any actual field research, but I worked with a lot of organizations that did. So my main findings was that the current state of rural electrification is okay, but really not great. So I mean, I don't know how much you know about this area in general, but typically rural electrification is supplied through micro hydropower. So for the general audience, that's like a small hydropower system. Like obviously Nepal is very mountainous. There's lots of hydropower reserves. But the way they've been designed typically is to provide a certain amount of power in the evenings, so the power runs continuously, and this power is provided a certain amount in the evenings, and it's been installed. You install a hydropower system, but unfortunately, if you want to provide any other electricity needs on top of what the system was originally designed for, it's actually really hard to add more hydropower. So you've already put your system in place, and then you're kind of stuck with it. So the research that the AEPC, which is the Alternative Energy body for the government of Nepal, and also Practical Action, which is actually a UK company but that was working in Nepal, what they're really interested in is seeing how you can change these systems to provide other forms of energy use. So not just lighting and phone charging, which is seen as the most basic aspect of stuff, but things like agro-processing. So there's lots of subsistence farming, how you can help people monetize that, get money from that, or other commercial businesses, which quite frankly wouldn't be suitable in the current scenario. So they were really interested in like what we could do with solar, with battery storage, even with things like diesel, to increase the capacity of those communities to produce more and economically develop.
Thank you.
So coincidentally, my uncle's actually been vaguely involved in a company that's trying to set up solar power, sell and set up solar power in parts of Africa, sub-Saharan Africa. I've been thinking, you know, with the kind of people having more and more phones now, as we saw with the Climate Edge actually, whether you could partner up with companies that are selling solar solutions, for example, and release an app that, for example, helps people model a system. You kind of partner with them, brand it to their system, and helps people model to find out, for example, what system would be best for them. Is that something you've thought about?
To be honest, not really. So it sounds like what you're describing is more suitable to like small systems. So the most applicable systems for what I kind of use is community scale. So in the order of tens or hundreds of households. There's a huge community in sub-Saharan Africa towards solar home systems. So a small solar panel, a small battery based on one household, which quite frankly is good, but again, not great. It means you can light your house and you can charge your phone, but you can't really do anything else with it. You can't have any economic development with that. You can't really have a refrigerator or a fan, which is what a lot of people want. So in terms of like an application for the end user, I don't really see the applicability of what I'm doing. Also because a lot of it is done through like the local marketplace. Like you have a company that's like, you know, your neighbor goes with this company, so you get that company as well. Or maybe that company wasn't very good, so you go with what the guy down the street went with. It's very much like word of mouth rather than necessarily kind of shopping around to see what's available within the whole marketplace.
Sorry, just a follow-on question from that. So I sort of heard about this concept of being able to solve all our energy needs by just creating massive solar farms and just distributing that across the world. As someone who's looked into the sort of commercial and technical aspects of these kinds of things, does that seem feasible? If so, when and how could we expect such a system to be deployed?
Sure. So to generalize quite a lot, if you're in the developing world and you want to supply power to your country, in general, there's a lot of blackouts, so there's not enough power to go around as is. So if you're making a large solar farm, let's say in India, then you would you supply power to the cities first, and then to the towns, and then to the villages. And it goes out like that. Quite frankly, because as a politician, you care more about the people in Delhi than you do in some village, which is unfortunate, but it's a political reality, and it's really not good, and that's kind of why I do what I do. So if you did have a lot of large, like centralized generation, so large solar plants, it would be good for meeting those challenges. But ultimately, if you wanted to reach those people in those villages, you would need some kind of distributed system, something next to those, so they can have the first rights to that power. That even if they're completely remote, then they'll never have access to that power. So you need something right next to them.
Okay, so here we are. I'm gonna let you do it, Johnny. I think you're
thank you. All right, great. That's a dubious honour, but yeah, thanks. Okay, so first of all, I'd say thank you to all of the teams. I mean, I think we were really astounded, actually, when we did this. This is the first time we've done it, and we really were taken aback by the sheer quality. And here you've seen the absolute cream of the crop. We've got some, fantastic projects here, and quite frankly, I think we'd like to fund, pretty much all of them if we could. But it was a really, really close competition, really, really high quality, guys. So first of all, I'd like to say sort of round of applause to all the contestants, because you guys were absolutely brilliant. And we also hope that, you guys have sort of learned a lot from this experience. You got a bit out of the coaching as well, and the sort of presenting in front of our sort of panel of cutthroat judges. I think they did their job of intimidating you guys fantastically well. So also a round of applause to our judges for giving up their time and asking some terrific questions. Okay, so here we go. This is the moment of truth, guys. So, better not mess this up. Right. So, in third place, we have Company FX. Round of applause, everyone. Well done. Congrats, mate. In second place, we had Climate Edge. Very well done. Well done, guys. And our winner of the inaugural programmable competition and the winner of £10,000 in proof of concept funding. This will go to further develop the software and hopefully turn it into something that will be sort of in use out in industry, which is really what we want to do with all of the technologies that we come across. The winner is FaceSoft. Well done. So thank you everyone for coming, and we've got refreshments next door, so everyone can just mingle, have a good time, grab a few sort of beers and snacks and soft drinks. Before we go, I'd like to say one more round of applause. First of all to the guys who helped organize this, Alex for his fantastic emceeing. For Nikita from Enterprise Lab for sort of sorting out the venue and the catering. It was really good, and a lot of the other organizational stuff. And also to Ishta, who did pretty much all of the work and let the three of us kind of take all the credit. So round of applause to Ishta as well. Yeah. And once again, I think the final message really is, guys, obviously sort of we had to have a winner, and being out there with the judges, I saw how difficult a choice it was. It really was. We expected them to be done in like 5 minutes, but they took quite a long time, and that was because the competition was so fierce and the standard was so high. And quite frankly, it's very difficult to sort of compare a sort of variety of things that have sort of impacts and potential in such different ways. And I'm really not, kind of blowing smoke when I'm saying, a lot of your things are going to go on if you give it the right support, and if you put the effort in and you have the right luck, you can go somewhere. So really keep working at it, and maybe with some luck and some help, and there's some fantastic support for you here in Imperial College from your peers and from Enterprise Labs and from ourselves. So get out there and keep working away, and get your software and your technologies to fulfill their potential. Thanks very much, guys. One more round of applause.
Word. Just very quickly, just to thank our partners at Imperial Innovations. Big thank you for putting all of this on. And secondly, for all those, all of you who've been through the program, please don't see this as the last part of the journey. Imperial Enterprise Lab is just a short walk over there. The judges really were so excited by all of your ideas. You've all got free reign of Imperial Enterprise Lab, of our facilities, our coaching, so please come and use us in future. Don't see this as the end of the journey. Come and see us. So just a quick thing on Enterprise Lab. Thank you.
You can really see the solutions that these guys have come up with being applied to the real world in a commercial environment.
What an incredible pitch session. We were so impressed with the diversity. The actual pitches themselves were extremely well developed, and the business models as well. You could really start to see the seeds of really scalable software businesses, of which there aren't actually a huge number of them currently on record at Imperial. So we're extremely happy to see a huge number of different types of software from what did we have? Everything from optimizing yields from renewable energy to face recognition software. It was extremely diverse.
We were genuinely pleasantly surprised because it was the first time we're running this. We didn't know if we're going to get any applications at all, let alone the quality and the quantity we had. It was actually really, really tough whittling it down to these finalists. So I can only just imagine how tough it must have been picking out a winner. And I think what was great in general was this notion that we have so much going on in the software space across all these different industry verticals. And I think that was a sort of main message of the night, I think, how much is going on at the college. And I think also how much of an underutilized or sort of untapped resource these different software projects are. I think there's so much happening at the college, so much potential. And yeah, we're just really excited to have launched this and hope we can do it again.
Yeah, I mean, I think it's very impressive really how London at the moment is a great place to do a technology startup, and particularly within the area of deep technologies like AI, machine learning, deep learning. And actually Imperial is one of the universities that is really at the top of this whole trend, and is bringing out some really great startups in this thing. So for once we're really competing with Silicon Valley, and we're certainly ahead of the rest of Europe in this field. So it's great to be in this position.
Thanks for the opportunity to pitch for Facesoft. Well, the experience was amazing. Actually, it's the first time actually I pitched for money. I pitched a lot for research money, never for commercial money. And it was quite nice, actually. I liked the experience a lot. I don't know why I won. I mean, that our technology is probably quite visible currently. I mean, all deep learning technology are quite visible, as well as technology regarding 3D phase reconstruction. The money are going to be used to rent some servers, as well as help us develop the first app to demonstrate our technology in cell phones. Thank you. Thank you.